All right, so I actually want to begin by reviewing the entire homework assignment that we had last week. I think I've assigned pretty much every problem, and so I'm going to go through each one at a time. So we have this position graph, and let's recall a couple things. When we have a position versus time graph, this means going forward. The slope is the speed, and positive slope means going forward, and negative slope means going backwards. And all of this, we're talking about buggies that are moving at a steady pace. So with this in mind, when we actually calculate the slope here, I'm going to do this using the math that you had in all your other classes. So the coordinate here is over 4 up 4, and I'm at 0, 0 at the origin here. So to get the slope, the velocity is going to be x2 minus x1 over t2 minus t1. Notice this is the position axis and this is the time axis, and I'm using those variables, and I do expect you to get used to that notation. So we got 4 minus 0 over 4 minus 0, and that gives me a slope of 1 meter per second. To get the units on any slope, you take the units of the rise, divide it by the units of the run. So we're going to have just 1 meter per second steady across there. Our speed never changes. So we have a 1 meter per second buggy that continues chugging along at that speed. Now here, the trick is we're going to split this into two pieces. And I'll just kind of illustrate with this little shape here, just to make a point. So first, I'm going to actually calculate the slope for this part and graph it. And that'll be fairly straightforward. So I have this point here, and it's at 2, 4. And here I'm at 0, 2 for my initial position. So let's get the first speed. This is what this little 1 means. And that's going to be 4 minus 2 over 2 minus 0. That's 2 over 2. So I'm getting a speed of 1 meter per second. And that lasts for 2 seconds. Like that. Nice flat line right there. Now for the second half of the graph, I'm simply going to move this here. So I'm at 2, 4 to start with. And then my final position is 4, 0. So when I calculate the second part of the journey, I'm going to end up getting 0 minus 4 divided by 4 minus 2. And when I simplify that, it's going to give me negative 2 meters per second. So I'll just immediately move my graph down to here and plot that. You don't need to continue these. A common mistake I see is that people kind of draw this little diagonal. Don't connect them. It's a sudden and abrupt change. And now I'm going to get rid of this little thing here, this little rectangle here, so you can see the whole thing. All right, so a similar approach here will actually give me, and I'm going to let you actually figure this one out on your own, or if you have questions, you can go ahead and ask me. But for the first second, I actually have a speed that looks like this. And then for the remaining 4 seconds, I'm actually going to end up getting, so I have V naught 1 second is going to be 2 meters per second. And V naught for the second part is going to end up being 0.5 meters per second. Or 1/2, 1 over 2 meters per second, whichever you prefer. So that's the first page.